Welcome to CXC Math TV. Usually we do it in the form of animation, but that's okay. We're gonna be looking at sequence and series for today. Alright, so of course you need to ask yourself these two questions. What is a sequence? And then you need to ask yourself, what is a series? So take 30 seconds, think about it. What is a sequence and what is a series? So a sequence. A sequence is just a set of numbers that they're going to obey a particular rule. So each number is related to the previous number by a specific rule. So for example, 2, 4, 6, 8, 10. Everyone can identify the sequence. If I ask you what would be next, you tell me 12, then 14, and 16, right? So the sequence is 2n. Right, so typically we say that the sequence, typically they use UN to represent the sequence. The sequence is 2n. When n equal 1, you get the 2. When n equal 2, you get 4. When n equal 3, you get 6, and so forth. That's the sequence 2n. Now when you have 1, 2, 4, 8, 16, notice this is 2 to the 0, 2 to the 1, 2 to the second power, 2 to the third power, 2 to the fourth power. Next one is 2 to the fifth power, 32. So the sequence is 2 to the n minus 1. So 6 minus 1 is 5. So the sixth term is 32. Down here, so you notice that, also, if you wanted the 10th term, you just plug in as 10, 2 to the 9. Now down here, notice this is what? Square numbers. So the next one would be 6 square, 7 square, 8 square. So the nth term is n square. That's a sequence. It's just related to the previous number by a specific rule. Now, if this is a sequence, the series is just adding up all the terms of a sequence. So when you add 2, 4, 6, 8, 10, 12, 14, 16, and so forth, when you add all of them, that's the series. So sequence is listing out the terms, series is adding up the terms of the sequence. Now you're going to see this weird looking symbol. This weird looking symbol just means summation. So this is the summation notation. This tells you where you start adding from. So you start adding from 1 in this case, and then we stop adding at whatever number they give you up top here. F of r is just the summation rule. It's just a rule for what we're adding. This way is to follow it, this example. Example, the sum from r equal 1 to 5 of r cubed. So this means we are summing from 1 to 5 for the rule r cubed. So that means you're going to plug in 1 cube. That's the starting position. Remember, this is where you start, and this is where you finish. All you're going to know is plug in what's the next number from 1? 2. So you're going to plug in 2 cube. After you plug in 2, what's the next number you plug in? 3. Then after you plug in 3, you plug in 4 cube. Then the last number 5, you plug in 5 cube. Then now you add those up, you get 225. So the sum from 1 to 5 of r cube is 225. Likewise, if you wanted to find the sum from 3 to 7 of 3 to the r minus 1. For this series, what they're asking you to do is sum from 3 to 7 for the rule 3 to the r minus 1. So you plug in r as 3 here first. This would be 3 to the 3 minus 1. Plus plug in r as 4 next, because this is just 3, 4, 5, 6, and 7. Plug in 4 next, then plug in 5, then 6, then 7. 2, 3 minus 1 is 2, 4 minus 1 is 3, 5 minus 1 is 4, and so forth. When you add all of these, you get 1089. Notice this one we started from 3 to 7. Alright, now there are some rules of summation you must know. The sum from 1 to n of 1 is n. So if you're adding 1, this is basically saying you're adding 1 n times must give you n. Example, the sum from 1 to 5 of 1. The rule is just 1. So you add 1 5 times. That must give you 5. If you're adding 1 25 times, that must give you 25. In other words, if I gave you this, the sum from, let's say, 1 to 15 of 1, that would just be 15. That's all we're saying. Alright? Now the next rule you must know is that the sum from 1 to n of k is kn. So, for example, we're adding the sum from 1 to 5 of 6. Notice if you plug in, when r is 1, you get 6, r is 2, 6, r is 3, 6, because there's no r to put in the function, right? Then when r is 4, 6, when r is 5, 6. You add 6 5 times, you get 30. Notice it's just 5 times 6. Notice if you add 7 25 times, it's just 7 times 25, which is 175. The next rule we must know is that the sum from any number to n of k times a function of r, you can factor out k, work out the sum from a to n of the function of r, then multiply it by k. To let it make sense, we use an example. Here, so 3 to 5 of 7r squared. If you plug in 3, you get this. Plug in 4, you get this. Plug in 5, you get this. Now, when you work all of these out and then you add them, you get 350. You could have factored out 7 first, then put in the 3, 3 square, put in 4, 4 square, put in 5, 5 square, then multiply all of that sum now in this bracket times 7. Notice this is 9 plus 16 plus 25, which is 50, and 50 times 7 is the same, 350. So another example, I could have given you the sum from 2 to 6 of 4r squared. I am saying, instead of you working out 4 times 2 square, then 4 times 3 square, then 4 times 4 square, plus 4 times 5 square, plus 4 times 6 square, I'm saying you could have just said this is 4 times the sum from 2 to 6 of r square. So instead, you just work out 4 in bracket, 2 square plus 3 square plus 4 square plus 5 square plus 6 square. Both will give you the same answer. That's all. Finally, the rules of summation tell you the sum from a to n of a function of r plus g of r. You can find the sum of f of r, then add it to the sum of g of r. Example, if I wanted, find the sum from 2 to 4 of r squared plus 3 to the r. You put in r as 2, that's 2 squared plus 3 squared. Then plug r as 3, that's 3 squared plus 3 to the 3. Plug r as 4, you get 4 squared plus 3 to the 4. This gives you 146. If you come over here and you work out the sum from 2 to 4 of r squared first, then work out the sum from 2 to 4 of 3 to the r, that would be 2 squared, 3 squared, 4 squared. Then plug in 2 to 4 would be 3 squared plus 3 cubed plus 3 to the 4. You still get 146. It doesn't matter how you decide to do it, you're fine. Alright, now let's do some questions now, right? It's always making sense when we do some questions. So what about some questions? Here are some questions we're gonna do. Evaluate the following. From k equal 3 to 8 of k over k plus 1. From j equal 4 to 7 of 50 minus j squared. And then we see the other two. Pause the video and attempt these questions, please. Alright, let's go. So this is the first one. The first one you need is the sum from 3 to 8 of k over k plus 1. Put in k as 3 first. That's 3 over 3 plus 1 is 4. Plus put in k as 4 now. That's 4 over 5. Then 5 over 6. Then plug in k as 6. That's 6 over 7. Plus plug in 7 next. That's 7 over 8. Then finally plug in k as 8. That's 8 over 9. So take out your calculator and add these things. Let's take out our calculator. So take out our calculator. 3 over 4 plus 4 over 5 plus 5 over 6 plus 6 over 7 plus 7 over 8. So we'll take that out and we'll add it and we'll get this, which is 4.115. Yes, sir. Yes, sir. Yes, sir. Sir, and oh, and we got 4.115, right? 4.115. Now, the next one is we need to add. The next one now we need to add. Oh, plug in from 4 to 7. So that would be 50 minus 4 square plus 50 minus 5 square plus 50 minus 6 square plus 50 minus 7 square. This is for number 2. Remember, this was 4.115. The next one is 50 plus 50 plus 50 plus 50 is 200 minus 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49. So you add these, this is 41, 41 and 36. Let me add these first. 49 and 41, you know that is 90. 90 and 36 is 90 and 36 is 126. I subtract, that is 74. This is 74. Next one now, number 3. Next one now, we're adding from 1 to 5, right? This is, remember you can always separate it, you know. You can break it up as a sum from 1 to 5 of 2r squared minus the sum from 1 to 5 of 2r. So in that case now, we have put in the 5, put in the 1 I mean, so 2 times 1 squared plus 2 times 2 squared plus 2 times 3 squared plus 2 times 4 squared plus 2 times 5 squared minus 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5. 2 times. So in that case now what we're getting is, this is 2, 4 times 2, 8, 3 squared 9, 9 2 is 18, 16 times 2, I believe that is 32, 5 squared is 25 times 2 is 50, and then we subtract 2 plus 4 plus 6 plus 8 plus 10. So in that case now we're getting 10, 28, 28 and 32, I believe that is 60, and plus 50 is 110. So this is 110 minus, this is now 18, 24, 28, and 2 is 30, that's 80. Now some persons might be saying, sir, why are you calculating without a calculator? It just feels funner to me, or more fun. For those who like correct grammar, more funner, or funner, however it is, right? I just prefer to do computations without the calculator. It's way more fun. Now, the last one, number 4 now, the last one. Alright, so going from 4 to 9. So in that case, this is 4 square in bracket, 2 times 4 minus 1 plus 5 square in bracket, 2 times 5 minus 1 plus 6 square in bracket 2 times 6 minus 1 plus 7 square in bracket 2 times 7 minus 1 plus 8 square in bracket 2 times 8 minus 1 plus 9 squared in bracket 2 times 9 minus 1. So in that case it is 16 in bracket, this is 8 minus 1 is 7, plus 25 in bracket 9, plus 36 in bracket 11, plus 49 in bracket 13, plus 64 in bracket 15, plus 81 in bracket 17. And there's no way I am going to add this without my calculator. 16 in bracket 7, plus 25 in bracket 9, plus 36 in bracket 11, plus 49 times 13, plus 64 times 15, plus 81 times 17. So we add them and we get 3,707. So this 3,707. So just to show you the answer then there, the 74, the 80, and the 3,707, right? So I make sure to type out the solution for you guys, for those who like to have typed solution. Now, the next thing we're going to talk about now is convergent and divergent sequences. Now, a sequence typically is said to be convergent when it is going towards a specific value. That's why I hear the term converge. So, for example, a sequence like it's a half, a quarter, 1 over 8, 1 over 16, 1 over 32. It keeps getting smaller and smaller, so it converges to 0 as it gets larger. Now, a divergent sequence now is one that is not converging. So, notice, this is just getting bigger. Next term would be 64, 128, 256. Going to infinity. It's getting bigger and bigger and bigger. So it's going to infinity as the number of terms gets larger. So same thing now. So we just look at convergent sequence. So now we need to talk about convergent series. So a convergent series, when you add them up, they're going to a finite value. So notice if you add up all of this, you're going to get roughly 1. When you add plus 1 over 64 to it, you're going to get roughly 1. So in that case, the sum is finite. The sum is going to 1 no matter as the number of terms gets larger. Over here now when you add it up, the sum getting larger and larger and larger. So it's going to infinity. In this case, it's divergent. So always remember, convergent just means it's going to a specific value. So now we have to talk about arithmetic progression. An arithmetic progression is a sequence in which each term differs from the preceding term by a constant. That constant is known as the common difference. So this is all you need to know. The first term, we generally call that A. We call our first term A. The common difference is D, and the common difference is found by the nth term minus the previous term before it, the n minus 1 term. The number of terms in the sequence is n. Now, it is written as this is the first term, so the next term is A plus D. The third term is A plus 2D. The fourth term is A plus 3D, and so forth. Typically, the last term then is A plus n minus 1D. Now, the sum of all the terms works out to be this formula, n over 2 in bracket 2a plus n minus 1 times d. That's the sum of all the terms in a arithmetic progression. You need to know this, this, you need to know this, you need to know this, and you need to know this. Basically, this page, you must know all of this for arithmetic progression. So if you're just watching, take out your notebook, write down these notes. You must know them. So look at this question, for example. It says write down the next term of the sequence. Without doing anything, we quickly can realize the next term is 33, right? To explain how you found your answer, you just add 6 to it, don't? Explain how did you find your answer. Realize you're adding 6. Now, part B, so we can tell them that we're just adding 6, right? Just out of simplicity, we tell them, so all we did was just add 6. Now it says Ryan said that the 20th term is 122. Explain why Ryan is wrong. Now since you're adding 6, right, you could keep adding 6, 39, 45, 51. 57, 63, 69, 75, 81, 87, 93, 99, 105, 111, 117, 123. So the 20th term would be, this is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the 20th term is 123. And so Ryan is wrong. Now, if you did it this way, that's fine. That's a whole heap of work. So just to type it out so it look more presentable. This is what you did, right? You said the next term was 33, and you said because each term differs by 6, you list out all of them and show that the 20th term was 123, so Ryan is wrong. Now that is not how I wanted you to do this question. I want you to know, go back and use arithmetic progression under this question. So using arithmetic progression, we said, remember it is 9, 15, 21, 27 given. They wanted the fifth term. First thing with arithmetic progression, we said the common difference D is the nth term. So D is equal to, this is part A, D is 15 minus 9, which is 6. Since D is 6, then we can proceed to say the fifth term. Remember, the fifth term, the nth term is this formula. Nth term is this formula. So we can tell them the fifth term now is equal to A is 9 plus n minus 1. So 5 minus 1, n is 5. 5 minus 1 times the common difference, 6. Is 9 plus 5 minus 1 is 4. 4 times 6 is 24. 24 plus 9 is 33. Notice we got the same 33. Part B, how did we get our answer? Using AP. Part C now was to explain why 122 was wrong. Now all you'd have to do is use what to find the 20th term. Finding the 20th term, you put n as what? 20. So the 20th term would be 9 plus 20 minus 1 times d, which is 6. Now 19 times 6 is 114 plus 9. That's 123. Look how easy that is. This will get 123 without having to list out all of them. So now we could clearly tell them, say Ryan wrong. So see it there? So we tell them that the first term is 9, common difference is 6. Finding the 20th term is 123. Right? That's it. Cool. Now, just to utilize the sum formula right here, so we decide to add the first 4 terms. Notice if you add the first 4 terms, you get 72. But if you use the formula right here, so, and put n as 4, it would be 4 over 2 in bracket 2 times a is your first term, 9. Remember the first term was 9 plus n is 4. 4 minus 1 is 3. 4 minus 1 times the common difference d, which was 6. You work that out, you get the same 72. Notice the formulas, them are making sense. So, we're going to do some exam questions now, right? We'll have to do some exam style questions. So, go ahead now and do this question for me. Pause the video, do this question. And AP is given by 18, 30, 42, 54, 60. Find the common difference. Then find the 8th term of the sequence. Then, given that the progression has 24 terms, find the sum of all the terms. Pause the video, answer the question. So let's go ahead and do it. Part A, common difference is the nth term minus the n minus 1 term. So 30 minus 18, which is 12. Cool. Part B now, 8th term. Now the 8th term, remember the nth term formula, and the nth term formula is what? The nth term formula we said was a plus n minus 1 times the nth term formula. So in that case, it is 18. 8th term we need, right? So the 8th term would be 18 plus n minus 1. That would be 8 minus 1, which is 7, times d, which is 12. And you put that into your calculator. You put that into your calculator, 18 plus 7 times 12. Work that out and we get 102. So the eighth term would be 102. The common difference 12, 102. Now part C, given that the progression has 24 terms, so n is equal to 24, find the sum of all the terms of the sequence. So the sum of the 24 terms, you have to remember the sum formula Sn is n over 2 in bracket 2a plus n minus 1 times d. So this is now 24 over 2 in bracket 2 times a is 18 plus n 24 minus 1, which is 23, times the common difference, which is 12. You punch all of that in a calculator. We have calculators, make use of it. So that is 24 over 2 in bracket 2 in bracket 18 plus 23 times 12. Punch all of that in the calculator and we'll get 3,744. 3,744. That is it. So this is 3,744. So just to show you the type solution, right? For those who who like it formal, right? This is the typed solution. Whoa, did I make an error somewhere? 18 plus 7 times 12. So this one had an error in it, not 140, should have been 102. So make sure you correct that. You notice in the type solution I made an error, should have been 102. Next question. It says in an arithmetic progression, the 20th term is 92 and the sum of the first 20 terms is 890. Find the first term and the common difference, then find the sum of the first 10 terms. So pause the video, go ahead, answer this question. Looking at this question, it's very different from what we've been accustomed to. This time they give us what? The 20th term. Now the 20th term they tell us is what? 92. No problem. What do we know? We know that the nth term is a plus n minus 1 times d. So in that case, 92 is equal to your first term we don't know, plus the 20th term, meaning it's 20 minus 1, which is 19. D, this is what we know. What else do we know? They told us that the sum of the first 20 terms, so they're telling us S20, the sum of the first 20 terms. Remember, sum formula is what? Write the sum formula down here. Sn is n over 2 in bracket 2a plus n minus 1 times d. So in that case, the sum of the first 20 terms is 2a plus 20 minus 1 is 19d, and this equals 890. Notice we have two equations. We have a plus 19d equal 92, and then we have 2a plus 19d equal 890. You see that? That's amazing, right? Oh, and then we had to remember the 2a, this part was multiplied by n over 2, 20 over 2 is 10, right? So in other words, if you simplify this equation, it was saying 20a plus 190d is equal to 890, right? I left off the times n over 2. And then now if you multiply the second equation by 20, you have 20a plus 20 times 19. Why did I do it that way? Maybe I should have divided through, but I already started this way. So 19 times 20, 380. This is now plus 380 is equal to 92 times 20, 92 times 20, 1840. If we subtract the two equations, 28 cancel 28. 380 minus 190 is 190d equal 184 minus 890. Put that in the calculator. 184 minus 890, which is 950. They will divide both sides by 190, and I think that should be 5. So just to show it in the calculator, 950 divided by 190, 5. Now once you get the common difference is 5, you're able to find the first term. Because then remember what was the first equation? The first equation was a plus 19 times 5 is 92. So a must then be negative 3. So notice we get our answer. For part A, we can tell them a equal negative 3, b equal 5. Then let's find the sum of the first 10 terms. For the first 10 terms is the formula, remember, n over 2, so it's 10 over 2 in bracket 2a. A is negative 3 plus n minus 1. 10 minus 1 is 9 times d, 5. Punch that in our calculator. 5 in bracket. A plus n minus 1 d, good. This is negative 6 plus 9 5 is 45. That's 39 times 5. And I can't multiply 39 times 5 out of my head, but I can multiply 40 times 5 minus 39 is 40 minus 1, so minus 5. This is now 195. So that's 39 times 5. The answer is 195. Now, once we get this would be the working out shown. I show you the full working out here. The first term is negative 3. The common difference is 5. Full working out here. Set up a simultaneous equation. Then I went on to show you the sum of the first 10 terms using the sum formula. So make sure you're taking pictures or you're writing your notes on these questions. Question 3. You know the routine. Pause and attempt. Let's go. It says in an AP, the first term is negative 10, right? So the first term they're telling us A is negative 10. The 15th term is 11. The 15th term, remember, is A plus 14D. Remember, the nth term is, remember, let me write it down at the bottom. A plus n minus 1D. So in that case, the 15th term, which is 11, this is negative 10 plus 14d. So if I bring it over, this is saying 21 is equal to 14d. So d would be equal to 1.5 because we divide both sides by 14. Let's see what they're going to ask now. And they say, and the last term is 41. Find the sum of all the terms in the progression. Now notice, we were able to find the common difference, the 1.5. Now they told us the last term is 41. Now the nth term is a plus n minus 1 times d. Now they told us that nth term is 41. And we know a is negative 10 plus n minus 1 times the common difference, which is 1.5. So bring over negative 10 to get 51. 1.5 in bracket n minus 1. So divide both sides by 1.5. 51 divided by 1.5. Punch that into your calculator. 51 divided by 1.5. We get 34. So 34 is equal to n minus 1. Add 1 to both sides, so n is equal to 35. Now, once you get n equal to 35, they say find the sum of all the terms of the progression. So now you can say, remember, Sn is n over 2 in bracket 2a plus n minus 1 times d. Now you put in n as what? 35. So now S35, the sum of the 35 terms, is 35 over 2 in bracket 2a, 2 times negative 10 plus n minus 1. 35 minus 1 is 34 times d, which is 1.5. Then we can just put that into our calculator. So put it into our calculator, 35 over 2 in bracket, 2 in bracket negative 10 plus 34 in bracket 1.5. I'll punch that in the calculator and we'll get 542.5. Whew, that was hectic. 542.5 is our answer. Just to show you the typed out solution, you can take a picture or you can write it down. This is the full typed out solution for you. And this is the next full typed out solution. Alright? Cool. Another question, another arithmetic progression, another one. It says a debt of 3,726 is repeated by weekly payments, which are in our arithmetic progression. The first payment is 60, and the debt is fully paid after 48 weeks. Find the third payment. Very good question. So pause the video, do this question. So the first thing they told us was what? They told us a debt, a sum. That's a sum, 3,726, and it is paid off weekly. The first payment is 60, and the debt is fully paid off in 48 weeks. N equal 48. So in that case now, we can set it up, set up our equation, right? That amount, the 3,726 is equal to, remember this is sum. This is sum. What's the sum formula? N over 2 in bracket 2a plus n minus 1 times d. So in that case, 3726 is equal to 48 over 2 is 24 in bracket 2a, 2 times 60 is 120 plus n minus 1, 48 minus 1 is 47 times the common difference. Now, we don't know that common difference, so just put d. Divide both sides by 24 first. So 3726 divided by 24 is 155.25. So 155.25 is equal to, remember we divide both sides by 24, 120 plus 47d. Subtract 120 from both sides. So subtracting 120 now will give us 47d. In that case, 35.25 is equal to 47d. So divide by 47 to get d equal. Put that in the calculator. Divide by 47. D equals 0.75. I want to get d equals 0.75. That's the common difference. Now we can find the third payment. The first payment was $60. So the second payment is 60.25. The third payment is $60.50. And if you didn't want to use that, what you could say is T3 is A plus 2B. So it's 60 plus 2 times 0.75, which is 61.5. Oh, I made a addition error. 61.5. That's it. Just to show you the typed out solution. Here it is. First payment. Set up your sum equation. Third payment. That's it. Now we're going to move on to geometric progression. Now, a geometric progression is a sequence in which each term is a constant multiple of the preceding term. So you must know these things with GP. The first term in a GP we call A. The common ratio is R, and it's found by dividing the nth term by the n minus 1 term. And generally, the first term of a GP is A, so the second term is A times R, third term is A times R squared, and for each preceding term, it does multiply by R. So typically, the nth term then, the nth term Tn is A times R to the n minus 1. Then the sum of a GP you use one of the two formulas. It's a in bracket 1 minus r to the n over 1 minus r, or a in bracket r to the n minus 1 over r minus 1. We use this formula when it is convergent. We use this formula when it is divergent. Cool. So I wanted you to think about this example. For example, 5, 10, 20, 40. If I were to ask you what's the next number, without a doubt you could tell me the next number is 80, don't? If I ask you to find the next term, you tell me 80. How did you get that 80? Just keep multiplying by 2. So really and truly, as we said, r is 10 over 5, which is the 2, or 20 over 10, which is the 2, or 40 over 20, which is the 2. Now, once you get 2, really and truly what you actually did was say the fifth term equal to ar to the n minus 1, but a first term is 5, r is 2, and n is 5. So 5 minus 1. So this is 5 in bracket 2 to the 4th power, which is 16, and 16 fives is 80. This formula works out convenient because what if you want the 20th term? There's no way you're going to keep on listing out all of them. What you just do is for the 20th term, you just say 5 times common ratio r to the 20 minus 1, which is to the 19. And you just input that in a calculator. That's all we're saying. Alright, so see it here. Observe your first term is 5. You can get r. Your fifth term is 80. We check it. We see it work out to be 80. Look another way to show the formulas are valid. If you were using the sum of if you wanted to find the sum of the first 5 terms, you could add them. 5, 10, 20, 40, and 80 is 155. Using the divergent formula, a is what? 5, r is 2. Using the divergent formula, 5 times 31 is still 155. Now, next thing with GP. As we said, we use two formulas for the sum. Convergent now, this is a convergent GP. It converges when the common ratio is between -1 and 1. Guys, this is extremely important. A GP is convergent when the common ratio is between -1 and 1. Now, when r is between 1 and -1, something unique happens. That means r to the n will tend to 0. Since r to the n tends to 0, this is what we call sum to infinity formula. So sum to infinity formula applies when it is convergent. Example, look at this: 64, 32, 16, 8, 4, and 2. A is 64. Nth term, so 32 divided by 64 is a half. So the sum to infinity, meaning the sum of all possible terms, would just be a 64 over 1 minus half, which is 128. That's all. Easy. So you know the drill. We must do somewhat exam questions. So pause the video, attempt these questions for me. Again, we find the common ratio first. Second term divided by first term, which is 3. Or you could say 9 divided by 3, which is 3. So the common ratio is 3. Find the eighth term. To find the eighth term, T8 is a r to the 8 minus 1. So it is a, which is 1, times r, 3 to the 8 minus 1 is 7. So work out 3 to the 7th power. Now it says, given that the progression has 24 terms, find the sum of all the terms. So then, S24, R is what? This is divergent, so we use a formula. Which formula we're gonna use for Sn? We're gonna use the one in bracket r to the n minus 1 over r minus 1. So it is 1 in bracket 3 to the 24 minus 1 over 3 minus 1. That works out to be 3 to the 24 over 2. That's it. So to show you the typed out solution, 3 to the 7th, 2187, and 3 to the 24 minus 1 divided by 2 is 1.4 times 10 to the 11. Next question. Pause the video and deal with this question for me. So again, A, common ratio. R is what? Second term divided by first term, 153 over 459, 1 over 3. Find the eighth term, T8 is A, R to the n minus 1. So A is 459, R is 1 over 3, n is 8, 8 minus 1 is 7. Punch that in the calculator, because I ain't working that out mentally. 459 in bracket, fraction button, 1 over 3 raised to the 7. Put that in the calculator and we get 17 over 81. So that's it. 17 over 81. Find the sum to infinity. Sum to infinity, since it converges, is 1 a over 1 minus r. So a is 459 over 1 minus 1 over 3. And you put that in the calculator. 459 over 1 minus 1 over 3. And you get 88.5. Easy. In that case, just to show you the answers, there we go. The common ratio, the eighth term, is sum to infinity using the necessary formulas. Right? And we're good. This one now, worded problem, getting a little more challenging. Geometric progression with first term and a positive common ratio has first term 75 and third term 48. Find the common ratio, the sum to infinity, the value of the largest term in the progression, which is less than 0.2. Pause the video, answer these questions. So these are the questions that are usually challenging, right? No problem. These are the ones that usually trouble us. Now, what did they tell us the common ratio is? We don't know. We need to find it. But they said the first term is 75, so A equals 75. The third term is 48. We know Tn is AR to the n minus 1. So T3 is AR to the 3 minus 1, which is AR squared. And T3 is 75, so 75 is 75. Oh, sorry, T3 is 48. Third term is 48. My bad. So T3 now is 48 is 75 r squared. Now find r, we divide both sides by 75. So now r squared is 48 over 75. I don't like using the calculator, guys. You can, but I'm just looking at numbers that can go into it. I think 3 can go into it. 3 into this 1, 3 into this 6, 3 into this 3 into this goes 25 times. So r squared is 16 over 25. So square root it. R is the square root of 16 is 4. And the square root of 25 is 5. That's a common ratio, 0.8. Now, part 2. Sum to infinity, a over 1 minus r. That is a, 75 over 1 minus r. And r is 0.8. So that's 75 divided by 0.2. That is the same as 75 times 5, which is, that's what, 150 plus 150 is 300 plus 75 is 375. So as I said, I love adding without the calculator. It's 375. Now they say the value of the largest term in the progression, which is less than 0.2. So we need the term in the progression that is less than 0.2. Now Tn is less than 0.2. Remember, Tn is what? AR to the n minus 1 less than 0.2. But A is 75, R is 0.8, raised to the n minus 1 is less than 0.2. So now we can divide both sides by 75 to get 0.8 to the n minus 1 is less than. Put that in the calculator. 0.2 divided by 75, which is a very small number, 1 over 375. Or, yeah, I'll use 1 over 375. 1 over 375. Now, in order to get n, we have to do what? Whenever the unknown is in the power, we take log of both sides. So the log of 0.8 to the n minus 1 is less than the log of 1 over 375. And we'll bring down the power. So n minus 1 log 0.8 less than the log of 1 over 375. Now, the log of 0.8 is negative. The log of 0.8 is negative. Now, since the log of 0.8 is negative, whenever you divide by a negative number, you do what? The inequality sign. Whenever you divide by a negative number, you change the inequality sign. So n minus 1 is now greater than this. Alright, so you have to remember that. Whenever you divide by a negative, you change the inequality sign. Think about it. Look, the log of 0.8 is a negative number. If you divide by a negative, you have to change the inequality sign. So now we have the log of 1 over 375. We divide that by the log of 0.8 and we get 26.6. Then we add 1 to both sides, so n is greater than 27.6. Since n is greater than 27.6, then n is equal to 28. So really and truly we need the 28th term, and the 28th term then is going to be a r to the 28 minus 1 is 27. So this is now 75 times 0.8 to the 27. That will give us the largest term less than 0.2. So put that in our calculator. 75 bracket 0.8 raised to the 27 and we get 0.18. So this gives us, that's the largest term, 0.18 less than 0.2. That is it. So just to type out the solution for you, there you go. That's a common ratio. That's the sum to infinity. This is n being 28. And so that term is 0.18. Solution typed out. Another one. Pause the video and do this one for me, please. Now to do this question, they say what? They say the first term is 64 and the sum to infinity is 256. Find the common ratio. First thing, sum to infinity is a over 1 minus r, and we're trying to find the common ratio. So 256 now is 64 over 1 minus r. So in this case now, if we flip it, we're saying 1 minus r is 64 over 256, which is a quarter is 1 minus r, and so r must be 3/4. That's our answer, 3/4. Then find the sum of the first 10 terms. Now S10, since r is 3/4, it converges. So then we're going to use the formula a in bracket 1 minus r to the 10 over 1 minus r. So it is now 64 in bracket 1 minus 3/4 raised to the 10th power over 1 minus 3/4. You put that in a calculator. Guys, we have a calculator, put everything one time. Don't waste the time, just put everything in it one time. Fraction button. 64 in bracket 1 minus fraction button 3 over 4 bracket raised to the 10th power, close the bracket, over 1 minus fraction button 3 over 4. Bam! That is the sum of the first 10 terms. 41.6. Just to type out the solution for you, there you go. And so that's it for today. That's it. We covered geometric progression, we covered arithmetic progression, we covered summation, we covered everything. So I really hope this video was beneficial. Make sure to just like and to subscribe. Alright? Keep practicing. That's the only way we get better at mathematics.